today, as mentioned, we're going to be discussing DevOps on the AWS cloud. My name is Mike Ruiz. I'm a solutions architect with Amazon Web Services. I work on the partner team. The partner team's job and the solution architect's job in the partner team is to help partners build cool solutions on the AWS platform. So today we're going to hear from three speakers. I'm going to hand over to Mark Vitner in just a minute. Mark works with Grindr, and Grindr has a really interesting story about scaling their service on the AWS cloud. And they've actually scaled to more than 1 million concurrently active users across 196 countries. So it's a pretty interesting story and a pretty interesting story of scaling. Mark will hand it over to Elon. Elon works with Datadog, and Datadog creates services for gathering up the events generated by those 1 million concurrently active users, and helping helping Grindr build actionable insights. And as mentioned, my name is Mike Ruiz. I'm going to discuss briefly the AWS architecture, and then I'll hand it over to Grindr. So traditional development models are becoming a little bit challenged, and we're having challenges operating them, and new technologies like those enabled by AWS and Datadog are rendering those traditional development models a little bit obsolete. So businesses, as we know, are increasingly software driven, and we're able to drive business value from software. And the demand then on the application teams that build that software is to iterate more quickly and bring services and features to customers. End users are also expecting of our development stacks and our application development teams continuous improvement on those applications. So I guess they probably always have been asking for continuous improvements, but we're now able to execute on that vision a little bit more fully and bring that business value to the customers more rapidly. To keep up with the demands on our developers as they build these applications and deploy them into production, IT really needs to be flexible and to be able to keep pace with these demands. And that's been very challenging in traditional data center or under traditional architectures. As our developers become more responsive and develop more to fully develop workflows and automation to drive applications into production more rapidly, IT has struggled to keep up with that pace of change and really put that infrastructure in place on time and in the capacities needed to support the applications. So I'm going to click next. So how can DevOps help? Let's take a minute to define DevOps. So lots of folks, I think, define DevOps slightly differently. It's really about bringing development and operations together and kind of removing those barriers between these disparate business functions. So DevOps is a set of practices that enable companies to innovate at a higher velocity to deliver applications to customers. So I think we can all agree on that as a baseline and speak through kind of the consequences of having a more rapid pace of change and a higher velocity to market. So obviously, if we have a higher velocity in our application development stack and application delivery, we're going to have better business agility. So we're going to be more able to rapidly respond to changes in the market, to different customer demands, and to help our customers have more success. Maybe counterintuitively, this higher velocity can lead to better application stability. So in the past, I personally equated kind of in traditional data center architectures and traditional development slash operations workflows, I equated higher velocity and change with a lack of stability. I think the opposite is true. The DevOps practices in coding our deployment, coding test, kind of getting really rigorous about how we deploy applications, and so moving away from hand scripting, moving away from a paradigm where developers are handing a bunch of code to an ops staff and asking them to run it in production, is going to result in higher stability and a better quality product for the customer. Obviously, as we increase velocity, we're able to meet customer demand in a much more seamless way. We're able to spend more time on innovation. So rather than have an ops staff spend months or weeks, building a physical infrastructure to support a new application, spend time fine-tuning that, looking for, issues with security or performance, we can spend that time instead on focusing on our customer and driving that value back into the application. And finally, and this is probably underappreciated as well, using DevOps practices and describing everything as code allows us to build security policy that's tightly aligned with our the needs of the application. So in the past, we might have had to draw a big bright line around the data center, get really prescriptive around security. And then when we went to production, we'd poke holes in that bright line, and we have a lot of conversation with our security operations team about safety. If instead we build our security policy into a package with our infrastructure and with our application, we're able to build security policy that's tightly aligned. So we have exactly the types of security policy, key management, access controls, the right ports with the right protocols open at the right time for the application to use them. And so obviously we're able to then decrease our development cycles, improve our time to market. Our deployment failures and rollbacks, because everything's automated end to end, we're able to automate deployment. We're able to also automate rollback. And obviously by describing everything as code, the infrastructure, the application, and the security policy, our time to recover upon failure is easy. We're just going to launch another copy of the stack. And I really wish I could press this button. So let's talk briefly about what the special features, tools, and practices that AWS brings to bear on these DevOps workloads. So as mentioned, we're going to describe everything as code. So since 2006, AWS has given you a set of APIs to describe storage, compute, and networking as code that you can check into a source code repository, version control like everything else in your application stack. Using AWS, we can define microservices. They're completely decoupled from each other. So rather than creating a set of services on a big monolithic architecture, we can create microservices that have embedded infrastructure, embedded security policy, and work together as a decoupled constellation. So if we have many application developers working on many aspects of the stack, they can have not only instances of their own application and dev, test, and production, but also instances of their own infrastructure to work completely independently. Logging and monitoring is really important as well. So we can build these really complex and kind of on-demand infrastructures and architectures that are totally decoupled. But if we couldn't see what was going on, then we wouldn't have a great security story. We wouldn't have a great operational reliability story. And so AWS provides the capabilities to have perfect visibility into your operational model from the application all the way down to the infrastructure and security concerns. And then, of course, AWS provides a variety of tooling around CI/CD or continuous integration and continuous delivery. We have products like Code Commit or Code Deploy, Code Pipeline for code orchestration all the way into production. And you can bring partner solutions as well. You bring your existing practice from your existing on-prem infrastructure and integrate it with the AWS APIs to build a custom workflow. So let's just double click a bit on infrastructure as code. So what does this mean? With AWS, you have the ability to provision servers, storage, and networking capacity as you need on demand. We know that, but you can also describe all of that as code and store it in your source code repository just like you would your application. So we're able to tightly align the needs of the application with the needs of with the infrastructure it needs to run and deploy it all as a single object on demand. So if you need a production clone to test a new code path, you can stand that up, test, and turn it off when you don't need it. We no longer have the case where, again, a developer will build an application or development team will build an application, they hand it to an ops staff, they kind of run it on the infrastructure, they may be guessing around provisioning, they may have had to pre-position that 6 months or a year prior to you needing it, and then we run into the issues of either kind of overstressing that architecture or maybe even worse, we're understressing that architecture. So with AWS, you're going to have just the right amount of infrastructure you need to run your workload. Again, you're going to make configuration changes repeatable and standardized by checking everything in as code with your standard source code repository techniques. You're going to build custom templates and AWS tooling like CloudFormation to deploy this infrastructure. You're going to use version control to keep track of everything. Let's talk briefly about microservices. I won't talk about serverless today, but there certainly are, quote-unquote serverless technologies available on the AWS platform to build microservices. But as a kind of a philosophy, we can decouple applications. We can deploy them as sets of smaller services that smaller teams are responsible for and build them on top of the infrastructure that's perfectly sized to support that particular service. So you can scale up and scale down using these techniques. We can define kind of rules between teams, expose our services to each other across our organization, through common APIs that are metered with the proper security protocols in place. And kind of key, we can build the infrastructure to support each microservice independently. So if one team would like to take advantage of Elastic Beanstalk and have AWS handle the details of scale in and scale out and load balancing, that's great. If another team is more in line with the Docker workload and they need Docker, they can use Beanstalk for that, or they can use the EC2 container service to manage their Docker constellation as tasks. And maybe another team wants EC2. Maybe they want virtual machines because that their application requires that. These folks can all use the services and the infrastructure they need, define it all as code, and then work together independently without collision. So all of that, reducing the friction, improves velocity. Really importantly is logging and monitoring. So AWS has an on-demand infrastructure. Folks can log in and scale out on demand. We can use infrastructure tooling for that to automate that process. But we want to be able to capture changes. We want to be able to analyze data that comes from changes. We want to be able to really understand what those stacks are doing so that we can assess if it's stressed, if it's idle. We need to maybe scale in, scale out. Maybe we're looking for security vulnerabilities. We have a compliance regime we want to comply with. AWS with CloudTrail provides a complete record of all the API use, where that API was called from, who called it, and what the arguments were. With CloudWatch, we have a stream of metrics flowing into another service. So we have a really rich set of data available. And folks like Datadog really pull that data together and allow users to create actionable insights, to actually take action on all of this data. And finally, AWS has a great continuous integration and continuous delivery story. So again, we're going to build, test, and deploy. We're going to build automation to do that. You can use code pipeline and AWS service to automate that. You can use code commit to store your source code or artifacts using your existing Git tools. You can use code deploy to actually deploy these artifacts onto EC2 or other services. Or you can bring your own. You can bring your, CloudBees is a great partner of ours, Solano CI, a variety of software as a service tooling to help you with this task, or of course you can completely customize it as you need. So then we'll just briefly overview as a review. You're going to automate system operations. So this is going to add velocity. You're going to get started quickly and pay as you go. This improves agility. You're going to improve visibility and security. So your entire stack, your firewalls, your quote-unquote firewalls, your load balancers, your compute and storage, and your application, your code repository are all available under a single pane of glass. You're going to leverage fully managed services. Where managing a service doesn't differentiate your company, you can consume, a partner solution. For CI/CD, you can use an AWS service. This extends all the way from DevOps workflows to configuration management like OpsWorks to fully managed database services like RDS. Then you're going to scale globally without infrastructure constraints. So, AWS has regions across the globe. We serve many disparate geos. You're going to scale in and scale out across those geos as you need to satisfy your customers. So with that, thanks for your time. I'm going to hand it over to Mark at Grindr to talk about Grindr's success on the platform and how they've scaled to over 900 million daily API calls and how they work with that scale of data.
Hey guys, my name is Mark Vitner. I'm the Site Reliability Engineering Lead here at Grindr, and I'm going to talk a little bit about the sort of challenges we had during our growth and how Datadog helped us with that. So we can start out with a little bit of background on Grindr. Grindr began in 2007 with the release of GPS in the iPhone, which really made the idea of a geolocated app possible. It was initially released in only two markets, Los Angeles and New York, but it quickly sort of grew into the phenomenon that we know today. Basically, Grindr was mentioned by Stephen Fry on Top Gear, and then everything grew so large so quickly that we've been sort of fighting to keep up ever since. So the takeaway is that the story of Grindr really is a story of technical debt. We've been trying to keep up since pretty much the very beginning. These are These stats just they show the sort of scale that we're talking about. You know, a million concurrent users, 5 million monthly active users, 900 million API calls, and so forth and so on. It's basically just some stats on how large we are right now, and basically there's a hojillion of everything. So, a few more stats. These sort of shift into sort of the background of what our day-to-day looks like. 10,000 geospatial operations a second, 300 daily uploads, et cetera, et cetera. But I mean, this sort of bridges into one of our other challenges, sort of the fact that we're active in 196 countries. So the wide distribution of our users is really a critical consideration in how we go about trying to achieve our performance goals. We have a small team, and we're trying to maintain a uniform, responsive user experience for a relatively huge number of users around the globe, and obviously that's kind of a challenge. So in terms of the challenges that, that challenge fundamentally involves monitoring, right? We're talking about tracking and analyzing a very large number of entities, calls, messages, et cetera. And we're trying to notice when significant variations, which are sometimes small relative to that total volume, occur within that subset. So, sometimes we're looking very specifically for a needle in a haystack. And this is a quote that I was surprised, that pretty well summarizes what we're trying to do. We pride ourselves in, enabling outstanding responsiveness to our users. And in order to successfully run a highly scalable and available cloud architecture, we need to find the right KPIs on potential issues within very short lead times. So yeah, this is basically our SRE and DevOps mission statement, the description of what we're trying to accomplish. Whoops. So before Datadog, we were having, plenty of issues with monitoring, right? I mentioned key performance indicators, which are metrics that fundamentally correlate to, things that we were trying to measure, the sort of health of our system. Before Datadog, we had trouble, frankly, determining what these were. We also had a lot of monitoring fatigue. Alerts would go off that weren't actionable, and eventually, as you would expect, people would stop paying attention to them. And then when there were alerts that were actionable, we wouldn't get them, et cetera. And I think most importantly, we couldn't sort of find the predictive metrics we were looking for. When you're working at very large scale, things can sort of become stressed very rapidly. In terms of the system health. So you see some kind of anomaly in the monitoring telemetry, and you maybe only have a few minutes to make some kind of adjustment before you've got a pretty significant problem. So you're trying to actually find metrics not that just express the current state of the system, but the state, the future state of the system, and that can be kind of tricky. But Datadog really helped us with that, and we'll go into a bit more on how this happened. But the upshot is that after we got our systems reporting into Datadog, we were able to address these challenges much more effectively. We now have nice, clean dashboards. The metrics in those dashboards are auto-discovered based on what's coming back from the nodes, and we can, differentiate what's important from what's not. Something else that helps us is the thresholds are resized on the fly based on, Datadog's algorithms. That helps us avoid, false positives, and we get, anomaly detection basically for free. So with that, that is basically our tee up, and I think I'll hand this over.
So as Mark and Mike mentioned, this is Elon with Datadog, and we are a hosted infrastructure and application monitoring platform. We tend to focus on things like on modern infrastructure. That's things like cloud, containers, microservices, auto scaling, all the different technologies that might lead you to having a very dynamic environment that you're interacting with. And we'll talk a little bit more about why that's important later on in the slides. These days, we're processing about 1 trillion data points per day within the Datadog platform, coming from our customers, and that in addition to a number of the events that we collect as well. And our goal is to help provide you with intelligent alerting, insightful dashboards, and and other tools to help you make sense of your infrastructure, to make big database decisions rather than than intuition or guessing. So as I mentioned, we're collecting nearly 1 trillion data points per day. We tend to collect our goal is to collect those from pretty much everything, help you create one centralized dashboarding and alerting system within the Datadog platform. As you can see from this slide, these are just a subset of the integrations that we have with open source commercial products, as well as with cloud solutions like Amazon Web Services and the various offerings that they have. You'll notice even other monitoring systems on this slide, and our goal is to help collect all that data into a single place so that you're not bouncing around looking at a dozen different point solutions or dashboards as you're trying to troubleshoot something in your infrastructure or determine if a change was successful or not. And so, I talked a little bit earlier about, why our focus on, our focus on modern technologies, things like cloud and containers. And so I want to take a little bit of time here to explain a little bit of how infrastructure and applications have changed over the years. On this slide here, you have in the leftmost column an example of what your data center might have looked like about 10 to 15 years ago. You had one piece of hardware that you had purchased, that you had purchased from a vendor. You had an operating system on it, probably a couple off-the-shelf components, and maybe in one application. These were single tenant, and so as Mike was mentioning earlier, when you needed more of these, you'd go ahead and place an order and have to plan for these long before the launch of your application or the new service that you were trying to make available to your customers. Over the last 5 to 10 years, folks have started to move to a more virtualized environment, allowing them to move a little bit more quickly, creating VMs where we deployed individual applications, but had multiple of them across an individual piece of hardware, such that we could manage that hardware slightly more dynamically, likely moving into places like Amazon or the cloud. These are things like your EC2 instances, where we're getting much better density on our hardware and the ability to manage it quickly, add and remove these hosts over time. So you'll notice we have a couple different applications here running on different VMs on top of a hypervisor, and then on top of hardware. There's definitely some level of dynamicism there. On the far right, what we have now is today's infrastructure monitoring challenge, which is even more fine-grained as we move into things like containers and ECS on top of the Amazon platform. You'll notice we have much smaller instances of each of our applications running on top of just enough operating system to get our applications going within a container. Those in turn on top of operating systems, which are in turn above the hypervisor and the hardware. The goal here again to get better density, to have a little bit more agility as we need to spin things up and down faster, and to simplify our deployments. Each of these columns in the middle and on the right have added significantly more dynamicism to our environments and made monitoring a little bit more of a challenge, and we'll get into more of that here shortly. So as we move into this new era of things changing all the time, all around us, it's important to have some sort of a strategy to figure out how to deal with all this data that we're collecting from those hundreds of Datadog integrations and from these containers that are constantly coming and going within our environments, or the VMs as well. And so over the last year or so, Datadog has been putting together a number of guides around how to make sense of your monitoring data, whether it be from a particular technology, or in this case, the monitoring 101 strategy that we're going to talk through here shortly. Frameworks that you can apply to any technology in your environment, regardless of the monitoring tool that you happen to be using. So there's a link here in the slides to our monitoring 101 guide. It'll talk you through alerting, collecting the data, and how to use it for troubleshooting. But I'm going to give you the sort of too long don't read version. There's the TLDR version. There's quite a bit more in those blog posts that I encourage you to check out. So one of the first things that we encourage you to do as you think about your application and think about what to alert yourself with is to categorize your metrics. Now we generally put together three. We've broken our metric. We encourage people to break metrics down into three categories. The first being work metrics, the next being resources and events. And so I'll dive in real quickly here onto what we mean by work metrics. Work metrics, if you think about your application as a factory, maybe producing cars as we have in this image here, work metrics are the throughput of that assembly line or that pipeline. It's the number of the throughput would be things like the number of cars coming off that assembly line. Success and error rates would be things like the number of cars that show up complete at the end of that process versus missing a hubcap or a crack in the dashboard. Those are the errors are those lemons. Performance might be the latency of how long it takes to produce any one of those individual cars or other other objects that you're manufacturing. And so these are the metrics that your customers really care about. These are the ones that your customers are coming to you and paying you for, that track the things that your customers are coming and paying you for, whether it be, in the case of our analogy here, a factory making cars, or in the case of your web application, API calls. So in the case of a web app, your throughput might be queries per second. Your success rate might be your 200 responses versus your error rates, which are your 400s or 500s. Performance being the latency on any one of those API calls. Resource metrics, on the other hand, are all the things that go into making them. Now, these are important because they do impact your efficiency. They do impact, if you don't have enough of them, you can't produce the work. So again, if you don't have enough tires to put on those cars, you're not going to be able to turn out more cars today to sell to your customers. Similarly, if you don't have enough compute or memory resources, you might find yourself in a situation unable to produce those API call results or that website traffic that your customers are looking for. So it's important to track these, but they're definitely not what your customers are coming to you for. Nobody ever calls you up in the middle of the night and says, your CPU usage is quite high. I'd like you to take a look at that. They're more likely to call you and say, hey, your APIs are not responding, and that's more likely what you might get paged on. So again, in the case of resource metrics, we're going to look at things like utilization. This is how much of the available resources that we have are we using. Saturation, saturation errors, and availability of those resource components. Events are the last category that I mentioned earlier, and these are things that you have done to your environment or have been done to your environment or to your business. So in the case of the factory, maybe you've released you've started to market a new model of this vehicle that you're producing, and you're going to have a ton more orders. Your backlog is going to have the backlog of orders has increased. You're going to have to do a lot more work to drain that queue. Maybe it's changes in the formula to the rubber and the tires or some other component in that assembly line. Or in the case of your application, most likely code changes. If you're changing the services behind that power your APIs, those code changes may result in the application being more performant. It may result in it being down. It may result in the ability to take more orders. There may be a number of different things that have come up here. Other types of events would be things like alerts. These are things that maybe have notified you that you're having an issue. Scaling events. Maybe you're using an auto scaling group, and the number of instances that you have is significantly increased or decreased over a period of time. And again, really any other decision that you might have made within your business or within your organization, whether it's to buy that Super Bowl ad or to have a sale of some sort. All these are the things that might drive more traffic or cause some sort of an outage in your environment or some sort of change in that performance. Now as we're diving into this, you might be asking yourself, which of these do I want to page on? When do I let folks sleep versus waking them up at 3 in the morning for an issue? And so what we encourage folks to do is to page on the symptoms. These are the things that, your customers are noticing. They're the things that our customers are coming to you for. So symptoms being maybe a change in your response rates over time. Again, that performance metric that we talked about under work. Error rates versus success rates, any significant changes in there. Maybe any significant changes in throughput around you're producing significantly more traffic or significantly less traffic than you normally would on that period of time. Again, these are symptoms that are true indicators of how your business is doing right now and how your customers are interacting with you right now. The rest of the metrics that we talked about, again, these being the resource metrics and the events, these are things that are going to help inform your diagnosis of what's going on in your environment. If you're not able to produce those API calls or one of those cards we talked about in the factory, maybe you reached a resource constraint and you just don't have sufficient memory or compute to produce more of that. Those are great resources. We'll go back and start to dive into those resource metrics as we're trying to figure out why our work metrics have changed. Similarly on events, if we're trying to figure out why something has changed in one way or another, we might overlay events like alerts or deploys or outages on top of our work metrics and try to see how they change, how those have affected our output over time. And so as we get these alerts and as we start our troubleshooting workflow, we're going to recurse on each of these layers, right? So every layer within your stack has its own work metric and has its own resources that it depends on. Usually deeper layers in the stack can be considered the resource of the layer that's having issues right now. So I would encourage you that regardless of where you are within your organization, whether you're a front-end developer working on a UI or somewhere in the middle working on some APIs, or all the way in the back end, interacting as a DBA on some databases, there are work metrics all the way through. Again, on the database side, maybe it's your SQL queries per second. On the web UI side, maybe it's queries per second or page views per second that you're looking at there. All of these things are interrelated, and so it's important that as you deploy your application, one of the first things that you do is try to figure out what are your work metrics and how do those interact with the resources below you. So as we're diving into, as we're applying this model, one of the things that we need to start to do is figure out what types of tooling and what types of solutions do we need in place to manage and monitor these dynamic environments in the cloud. One of the things that so the next couple of slides as we'll dive in are focused on sort of features and functionality that you might want to look for in your monitoring solutions. The first being, we want a tool that will give us visibility across all of the different components that we interact with. Those might be Amazon services, everything from RDS to EC2 to Beanstalk or some of the other pieces that we've talked about here, ELBs, etc. Or they might be off-the-shelf components or custom components that you've built. We want to be able to look at all of those things in a single set of dashboards, be able to alert from them from a single tool, so that we're not bouncing around between different tools in an incident or as we're trying to decide what's going on, trying to decide what to do next in one of our deployments or infrastructure changes. The next thing I dive into is trying to start to look at your alerts and the types of alerts that you're sending out. What you see on the screen here is a fairly traditional alert. This is something you might be used to getting on your pager or in your inbox. It's great that DB server 1 is down, but what does that database server do, and how does it impact your customers right now? And what do I do with that when I wake up in the middle of the night to an alert? I may never have heard of this before. It may have been built by one of my colleagues or one of my one of my predecessors. It's hard to say, and it's not really clear from above this how the application is impacted either. So we think it's important that when you create your alerts, you're a little bit more clear as to what's going on. So in this case here, you'll see an example of the type of alert we would encourage within the Datadog organization, and these are the types of alerts we would create for ourselves internally as we're monitoring Datadog with Datadog. In this case, what we're talking about is the alert message is very clear. The homepage response time is above 3 seconds. After 3 to 5 seconds, our customers are going to get bored or frustrated, and they're going to abandon. Let's investigate that, and then we dive into, do we need more capacity? Here's some links to how to go and spin more of that up. Is there a runbook for this? Great, link to that from the alert. Who do you call next? These are all critical pieces that should be in your alerts, so that when your engineers are coming online in the middle of the night to interact with an issue, they're not trying to do guesswork as to where this component fits within your infrastructure and how your customers might be impacted. So again, the 3 rules of alerting we would say is tell why this thing is important, whether it's an individual component or a service as a whole, or one of those work metrics that we talked about earlier. What should the person do about it? Should they spin more infrastructure up? Should they call somebody? Should they deploy some code? What is the next step for them there? And then finally, what do you do if you get stuck? Who should you call next? Is there another team? Who owns the service? Who do you escalate to? But the most important thing across all of these things is that every alert should be actionable. Don't alert your teams on individual components or metrics that they might need to respond to. Your pager is not your email inbox. It is not a thing that you get to later. It is a thing that you're going to interact with right now. And so every alert must be actionable, and it should be something that you're going to readily dive into as soon as you get that alert. If you're alerting 10,000 times a week, your team's just going to take the battery out of that pager when they go to sleep. So let's make sure that those alerts are actionable and insightful about the state of your service right now. Next thing I'd say is that you might want to look for is tooling that focuses more on dynamic environments. So what we have on the screen here is sort of an example of a Nagios configuration or a static configuration file here on the left. If you hook this into auto-scaling, it doesn't matter how amazing you are with your configuration management, whether it be Chef, Puppet, Ansible, or Salt, or with your cloud formations or anything like that. Amazon's going to be auto-scaling your infrastructure up and down for you based on load and based on other patterns in your traffic. Your configuration management tooling is not going to keep up with that as fast as auto-scaling and other pieces are, even if you turned your converge times way down. So you hook these two together, and really what you're going to do is get paged quite quickly. These are not a recipe for success. You want to be looking for solutions that let you do this dynamically. So the approach we take, and we encourage you to look for in the tooling that you're interacting with, is to find tools that will work with tags. So all of our infrastructure providers these days provide tags, everything from Amazon itself within EC2 and all of the other resources that it offers, up through things like containers with Docker, offering tags and labels there as well. All of these things offer some metadata about your environment that let you better understand where these metrics are coming from and sort of the state of that environment that the location that those metrics are coming from, and sort of some additional metadata and information about why they're useful and what they relate to. So to give you an example of this here, on this slide we have an example of a data point, and I mentioned earlier that we're bringing in nearly 1 trillion of these a day. On the left you have the metric name. This is the thing that you are measuring and what it is. In this case we're looking at network traffic, bytes received. The next column over is going to be the value, how much we're at, what was that measured at the point we collected this data point, or how much. A timestamp, because it's clearly important to know when, as we're looking at time series data. And then finally the where, which is in this case the tags, whether that be your file server or the region that you're in, or some other value. And so as you can imagine, we might want to be able to, as we're looking at these data points, we want to know where they're coming from, and that's where that final tag comes into play. So how does this apply in real life? Well, we're looking here at this stack of instances, and you'll notice we have all kinds of different instances put together, everything from databases to caches to application servers, and across different regions and availability zones. We also have different instance types. And so as we bring in tags with our different metrics and query our time series data store, we're going to be able to slice and dice across any one of these axes. So in this particular case, I may have wanted to know a lot about all of the T2 smalls I have running, and so you can notice that middle row there is yellow because I've created a query about specifically T2 smalls, and I can see data across my database, caches, and app servers. Alternatively, I might have wanted to slice across a different axis and look at only the caches or only the app servers or only the databases. And this is great as I'm looking again at those work metrics or at those resource metrics, trying to dig in around my environment. Now, what these tags allow you to do is ask better questions. So you're able to say, show me all of the, you'll be able to ask questions like, monitor all the containers running a particular image, in this case web, across a given region, maybe US West 2, across all availability zones or maybe a specific availability zone, and on certain instance types, things like that. And so what you can think of is you're constructing a query using those tags, as predicates. And in this case, any one of these bolded or underlined terms is either a tag or a predicate that we're we're taking a look at in our alerting or dashboarding query. And so with that, we've sort of reached the end of our presentation here today with Amazon and Grindr. We've got some great resources for you here at the end of this slide deck, linking to our Monitoring 101 guides, as well as some details on the power of using tag metrics.
So I'd like to thank once again Mark Vitner from Grindr and Ilan Rabinovich from Datadog for joining me, Mike Ruiz, Partner Solution Architect with AWS, for the DevOps presentation today. Thank you so much.